at present is 2.5 quintillion bytes of data. 2.5 quintillion bytes of data. 1 quintillion byte of data is equal to 10 lakhs terabytes. 1 quintillion bytes of data equal to 10 lakhs terabytes. That much information nowadays producing throughout the globe. So because of the rapid growth in Internet of Things, the domain IoT, the information is generating in a very rapid pace. As per statistics, in the last 10 years itself, around 90% of the data that is digitalized is generated. In the last 10 years itself, 90% of the data, total data that is digitalized is generated. So there is a lot of necessity towards securing this much information which is digitalized. So that's why this is the emerging topic in the present technical world. This is the reason today I have chosen this topic, network security. Let's move to the contents of this session. Here briefly, since the network security is a very broad domain, I would like to bring some brief knowledge over the concepts in network security or computer security. See the topics. What is computer security? CIA triad, security attacks, security mechanisms, research scope, and finally virus and worm. Virus versus worm. Okay, let me define this computer security. There are so many definitions are available throughout the globe. Among them, I brought the definition from NIST, National Institute of Science and Technology, which is an agency which is promoting innovation and industrial competitiveness in the United States. Very repetitive technological society. As per that NIST, the definition for computer security is the protection afforded to an automated information system in order to attain the applicable objectives of preserving the integrity, availability, and confidentiality of information system resources. Mainly, the NIST has focused integrity, availability, and confidentiality of information system resources. As we all know that confidentiality is hiding information from unauthorized users, unauthorized access. Coming to integrity, data integrity is very important. Whatever the information sent by the sender, it has to reach to the receiver without any altering, without any modification. The message has to reach to the receiver. That is also one of the security objective. And availability, the computing resources and the information to be made available to authorized users whenever they want without any interruption. This is also one of the major objective of computer security. See, as per NIST, there is National Institute of Standards and Technology, which is promoting innovation and industrial competitiveness in United States for advancing the science, standards, and technology. It has defined network security with a model that is called as CIA triad, where C stands for confidentiality, I for integrity, A for availability. These three confidentiality, integrity, availability services are going to preserve, protect data and services. And NIST has also listed these three as fundamental security objectives for information and information systems. Okay, let's go through confidentiality. As per definition, it assures that a private or confidential information is not disclosed to unauthorized individuals. Only authorized people can access confidential or sensitive information. Integrity assures that information and programs are changed only in a specified and authorized manner. Only authorized users are allowed to modify or change the information. Unauthorized access to be avoided. Availability assures that system work promptly and service is not denied to authorized users. Always we should make it available, both data and services, to the authorized users. Simply, okay, while we are protecting all these things, we may come across several kinds of attacks. Broadly, these attacks are classified into two types. Let's move through what is an attack. Any action that compromises the security of information owned by an individual or an organization. The data may belong to either individual or organization, should be protected. Okay, if any action that is compromising the security of information owned by this individual or organization is called a security attack. And the security attacks are broadly classified into two types. They are passive attacks and active attacks. When we name all the attacks, is a very big list. Here, generally, we classify them as broadly classify them as passive attacks and active attacks. What is a passive attack? A passive attack attempts to learn or make use of information from the system but does not affect the system. Here, as part of passive attack, we call him here attacker. He listens to the communication channel continuously to access the information that is exchanging between sender and receiver, or exchanging between two users. He continuously monitors the communicating channel, but he will not alter or modify the transmitting message over the communication channel. Only the objective of the attacker in case of passive attack is he listens to the communication channel and come to know what information the users are exchanging with each other. But what is the use of this kind of attack? Here examples: release of message contents, traffic analysis. Okay, the attacker comes to know what messages they are exchanging. Mostly the confidential or sensitive information is not transmitted as it is. They are converted into ciphertext that is not understandable format and transmitted over the communication channel. So even the attacker access over the communication channel, the message may not be understandable to him, even though he tries to make use of that information with another technique called as traffic analysis. This is also one of the use for an attacker through passive attack. Traffic analysis. Even though the transmitting information is not understandable to the attacker, he tries to get benefit to the information doing analysis of information. For example, if an attacker is focused on communication channel between two users, he might know the domain in which the users are going to communicate. Based on the domain, he might guess what information they are exchanging. For example, in a banking domain, the people who are exchanging the message from banking domain, both are bank employees. Mostly the information what they are exchanging may contains account numbers, the amount transaction IDs, something else. Okay, the size of based on the size of the information they are exchanging, how frequently the users are exchanging the messages. Based on these statistics collecting over a period of time, the attacker may guess the kind of information they are exchanging, even though the information is in the form of ciphertext, that is not understandable format. That is about passive attack. Let's move to the another attack, active attack. An active attack attempts to alter system resources or affect their operation. Okay, unlike passive attack, not only listens to the communication channel. Here in the case of active attack, attacker captures the information transmitting over communication channel. He is going to either modify or retransmit the same information to the receiver. Either modifies the transmitting message or he is going to retransmit the same message again. There are so many benefits to the attacker by doing this. Okay, some of the examples of active attacks are masquerade. A masquerade is nothing but attacker pretends to be user of authorized person. Okay, attacker pretends to be authorized user. Okay, by getting the credentials of sender, he will send the message again to the same receiver. Here, this kind of active attack is called as masquerade. And replaying, suppose one sender is transmitted a message, send some money to me, or sends some specific amount to me. By getting the credentials of sender, again the same message, the attacker is going to replay after some time. He might be benefited. And denial of service, this is a popular kind of attack, denial of service. Okay, service is denied to the intended or authorized users through the active attack. In passive attack, the attacker is just listening to the communication channel and trying to know what information they are exchanging over a communication channel. In case of active attack, not only listening to the communication channel, but also he tries to modify or alter the transmitting message. Then comes to security mechanisms. Okay, in order to protect the data from several attacks, what are the security mechanisms we have? As part of this presentation, I brought the popular security mechanisms.
Sir, excuse me, sir. Your voice is not clear, sir.
Hello?
Yes, sir.
Hello?
Ah, yes, sir. With some disturbance is there, sir. Voice is not clear.
Yes. Hello.
Now
Is
it's
that
clear, sir.
now it's
Yes, sir.
clear?
Now voice is clear, sir. Yes, yes, sir.
From my end, I have no problem. I think so. Okay. Let me continue. Okay. My slide is visible?
Yes, sir. It's visible.
Okay. Okay. Security mechanisms. To avoid several kinds of attacks and protecting the data and services, there are so many security mechanisms are available. Here, as part of this presentation, I brought some popular security mechanisms. Encryption. Encryption is a way of scrambling data so that only authorized parties can understand the information. That is, while sender sending the information, he encrypts the data and transmits that encrypted information. After encryption, the result is called as a ciphertext, which is in not understandable format. You can look at the diagram. Here there are two kinds of encryptions we have, encryption techniques we have. One is symmetric encryption and other one is asymmetric encryption. In symmetric encryption, while converting the plain text into ciphertext, that is not understandable format, sender uses an encryption algorithm. For that algorithm, the inputs are plain text and one key. Plain text and one key. By making use of the plain text and key, the algorithm produces output which is called as ciphertext, which is not understandable to anybody except sender and receiver. When the ciphertext is transmitted over a communication channel, even the attacker gets the copy of the ciphertext, he is unable to access the information, he is unable to know the information. When ciphertext reaches to the receiver end, the receiver also have the same copy of the key that is used by the sender. By using that key, he decrypts the arrived message and gets the plain text. He decrypts the arrived message and gets the plain text. Here, this is general process of encryption. Sender encrypts the message or plain text by using a key, and the output of the encryption algorithm, that is ciphertext, transmitted over the communication channel. At the other end, receiver also makes use of a key, decrypts the ciphertext and gets the original message, that is plain text. This is general process of encryption. Here the encryption can be in two ways. We can do encryption in two ways: symmetric encryption and asymmetric encryption. In symmetric encryption, both sender and receiver uses the same key. Sender uses one key for encryption. At the same time, the receiver also uses the same key for decrypting the ciphertext into plain text. Both users uses the same key. Coming to asymmetric encryption, it is also called as public key encryption. Here, sender uses one key. Here, in this kind of encryption, there are two keys. One key is called as a public key, other key is called as a private key. Sender uses the public key to encrypt, whereas sender uses the public key of the receiver to encrypt the message, and the ciphertext is transmitted over the communication channel, and receiver will decrypt the arrived message by using its private key, so that it will get the original message. See, sender will send the message by encrypting with the public key of the receiver to whom he is sending the message, whose public key is used to encrypt the message and transmitted the ciphertext. Upon arrival of the ciphertext, the receiver will decrypt the message by using its private key. This is called as asymmetric encryption. Okay, as I told, components of encryption process here are plain text, ciphertext, key, and algorithm for encryption and decryption. And let's consider simple traditional example. Here I brought traditional Caesar cipher. As per Caesar cipher, the word zebra is translated into ciphertext as CHEUD. CHEUD. Here the length of the plain text is equal to ciphertext, and the algorithm for converting the plain text into ciphertext is very simple. See here, C stands for ciphertext, C equal to P plus 3 mod 26, where P is the plain text. One letter at a time is going to be encrypted. First Z is picked, and in alphabets, if you assign the values 1 to 26 from A equal to 1, B equal to 2, and so on up to Z, 1 to 26, if you assign the numbers to alphabets, Z carries the number 26. So Z is replaced by which letter in the ciphertext? Z is replaced by C. How it is possible? See the algorithm. First letter Z is picked. What is the equivalent assigned number for Z? It is 26. 26 plus 3, 29. 29 mod 26. Mod operation yields output, that is nothing but remainder of division operation. So what is the remainder? 3. Okay. 3 is assigned to which letter? In an alphabet, A equal to 1, B equal to 2, C equal to 3. So Z is replaced by C. Then likewise for E, E equal to 5. 5 plus 3, E is assigned to number 5. 5 plus 3, 8. 8 mod 26. What is the result of modulus operation? If numerator is lesser than denominator, numerator is the result. So 8. So in place of E, what is the letter we are going to replace? That is H. Simply I can say here each letter is replaced by the next third letter. The next third letter in alphabets. Coming to Z, here the alphabets are assumed to be circle. A to Z, again after Z, we again come to A. In a circular manner, we have arranged the alphabets. So Z is replaced by A, B, C. After Z, what are the letters we have in a circular fashion? A, B, C. Likewise for E is replaced by the next third letter. After E, what is the third letter? F, G, H. So E is replaced by H. So B, C, D, E. B is replaced by E. In this way, the word zebra is translated into ciphertext. This is very simple traditional Caesar cipher. This is the algorithm for encryption. And for decryption, just from the ciphertext is the input for decryption algorithm, where you take, if the output is plain text, sorry, here it is a P. From ciphertext, we need to subtract 3 mod 26, we get the plain text. In generalized version, this is the Caesar cipher is used by Julius Caesar for exchanging their messages. In generalized version of Caesar cipher, the key may be any value from 1 to 26. Here, each letter is replaced by the next third letter as part of traditional Caesar cipher. In a generalized version, not only third letter, each letter in the plain text may be replaced by any letter. The popular examples for encryption, symmetric encryption, are Caesar cipher, DES, IDEA, Blowfish, RC4, and one more also popular one, AES, Advanced Encryption Standard. Example algorithms for comes under asymmetric encryption or public key encryption includes RSA, Diffie-Hellman, elliptic curve cryptography, ECC, etc. Here, what is the purpose of encryption? Encryption is going to hide the transmitting message from unauthorized users. One of the objective of computer security as per CIA triad. As per CIA triad is confidentiality. In order to achieve the confidentiality, encryption algorithm we used, which is going to hide the transmitting message from unauthorized users. And coming to hashing, another objective in CIA triad is preserving the integrity of the transmitting message. That is, the message what we are exchanging by the sender and receiver is not altered. It should not be altered or modified while it is transmitting over the communication channel. In order to prevent the integrity of the message, here one of the popular technique we use is hashing. Hashing is a technique or process of mapping keys values into the hash table by using a hash function. Simply here, hash function, look at the diagram. All these are the messages that we are going to exchange. Left side keys are nothing but the messages which are going to exchange. Each message is given as input to hash function. Then it assigns one hash value as per algorithm of the hash function. It assigns one hash value to each message. The hash function generates the fixed length hash value for a variable length plain text. Whatever the input, the plain text or the transmitting message, whatever the length of the transmitting message, it generates the fixed length output. Here, the available hashing techniques generates the fixed length output for any variable length input is up to 512 bits. Hashing is used to, as I told, is used to preserve the integrity of the transmitted message. Example techniques for hashing are message digest, which is going to generate the hash value of 128 bits, SHA secure hash algorithm, it has so many versions. It generates hash value of 224 bits, 256 bits, 384 bits, 512 bits. Total four versions. Security hash algorithms we have, secure hash algorithms, and RIPE-MD, which is going to generate, which is also available in 4 versions, which generates 128 bits, 160 bits, 256 bits, 320 bits, and Whirlpool hash algorithm, which is going to generate 512 bits of the hash value. Main objective of hashing technique is to preserve the integrity of transmitting message right from sender to the receiver. While it is transmitting over a wired or wireless communication channel, the information should not alter or modified, should not be altered or modified by any attacker or intruder. So to maintain this integrity, this hashing technique we use. And one more thing, very popular, we're all aware of this, digital signature. To verify the arrived message comes from intended sender or not, to verify the authenticity of the sender, we require a security mechanism called as digital signature. A digital signature is a mathematical technique used to validate the authenticity and integrity of the message, software, or a digital document. From whom actually we received the message. Okay, see, simply this is very simple diagram, very easy to understand. See, signer, the person who is sending the document or a communication channel or computer network. Here the data which is going to transmit, that is given as input to hash function. Then hash function generate the hash value for variable length input, whatever the input. It generates pixel length output, that is hash value. Then this hash value is given as input for signature algorithm. Here the signature algorithm, or you can treat it as an encryption algorithm. It takes hash value as one input and key as another input. Here the key is private key of the signer, that is the person who is sending the document. Then it generates the output of this algorithm is the signature. It is called as a digital signature. The digital signature is attached to the original message what we want to transmit and transmitted over the communication channel. And coming to the verifier end, at the receiver end, the receiver again, after receiving the message, again the verifier also generates the hash value through by giving as input to hashing function. Just like signer, data is given as input to hash function, hash value is generated. In the same way, upon arrival of the message, the verifier also gives data as input to hash function. The output is hash value. And coming to the signature, what it received, again this signature is given as input to verification algorithm. From this verification algorithm, the receiver, that is verifier, gets verifier also gets hash value. Here for this verification algorithm, one more input is public key. Here signer's private key is used to encrypt the transmitting message. Here the signer's public key is used to decrypt the received message at the receiver end. Then this is called as verification algorithm. The output of this verification algorithm is the hash value. Here for the received original message, again hash value is generated through the signature, that what we received, again hash value is generated. Both hash values are compared. If both are equal, same, then only the receiver trusts that the arrived document is from the correct sender. The receiver trusts that arrived message is from the correct sender only after comparing the two hash values, which becomes the similar. And coming to the final objective of computer security in the CIA triad, confidentiality that we discussed, one of the technique encryption for integrity, hash function, and digital signatures. And coming to availability, here in order to make the data and services available to the authorized users, high availability systems are introduced. Here, it uses some architectures that are specifically designed to improve availability when it is needed. Mainly, this high availability computer system, high availability systems architectures targets on hardware failures, upgrades, or power outages to help improve availability. Hardware failures, generally a parameter, a metric we have MTTF, mean time to failure. If it is more, then the chances or frequency of failures is also very less. As much as possible, we have to increase the MTTF value. In the same way, the architectures are designed to avoid these hardware failures, upgrades, or power outages so that the data and services became available to the authorized users always. And coming to the research scope in this network security, there is a broad research scope into security in cloud computing. Nowadays, we are all hosting our data and services. We are all hosting our data in cloud, and also we are getting the services from the cloud. So we need to trust the cloud service provider. In order to trust the cloud service provider, they have to provide the required security for the data and services of the users. Still, there is no standard which is going to assure 100% security to the data. Still, so much research is going in cloud computing, security in cloud computing. And one more interesting domain in this network security, that is embedding at artificial intelligence into security, training the algorithm to protect the data and services automatically, not in the defined, not defining a particular kind of attacks or something else. The algorithm itself keeps on training and identifies attacks, thereby protects the data and services. And last but not least, IoT. Through IoT only, that much information is generated per day throughout the globe. So security in IoT is also very much emerging research domain. And finally, virus versus worm. What is a virus? A virus is a kind of malicious computer program which then executed replicates itself and inserts its own code. The examples are class I love you, WannaCry, GS, etc. etc. And worm, a computer worm is a type of malware that spreads copies of itself from computer to computer. The examples are Nimda, Melissa, MS Blast, MS Blast, Sobig, Storm, Jerusalem. See, the major difference between virus and a worm is when virus is entered into our computer, user interaction is required. He has to open either a file or he has to make use of certain service. Thereby, the virus enters into the system. Then coming to the worm, once worm is entered into our computer, not required human interaction or user interaction is not required to spread the worm into our system. Itself, it replicates the worm throughout the system. That is the difference between virus and worm. Virus and worm both are malicious program. In order to active virus, here the user interaction is required. He has to either open a file or execute some file, something else. User interaction is required to replicate this virus to different locations in a computer, whereas worm, no user interaction is not required. Upon arrival itself, the worm itself starts its replications throughout the system. Okay, this is about my presentation today.
Thank you, sir.
Any
Thank you very
queries?
much. So
Any
now I
queries?
request participants, if you are having any queries or doubts, you can ask to the resource person. Okay, sir. Thank you very much, sir. Thanks for your nice lecture.
Okay,
And I
thank
thanks
you.
all the participants for staying complete session. Thank you very much. with this, now we end the session, sir.
Okay, thank you. Thank you.
Thank you.